Here we have our more complicated formula for the compounding, which we're not calculating simply the interest, as I was with the simple interest problems, but something I've called there P1. I can call it then the future value, right? How much money am I going to have? P1 is the principal I've got when my investment runs for a time, and all the interest I own is added to the principal, is put back into the investment. So this is the general formula in symbols, and to write it out in words, you can understand that as the future value, what the investment will be worth, how much money will be in it in the future. That's P1. P is the principal, how much did you put down. The figure in parentheses includes the rate, which we understand as the annual rate, added to 1 because you're keeping your principal. So P times 1 is going to be 1. And that taken to a power that represents the time. Now, if you think of that strictly through years, that's the way we were considering the problem last time, you get... it's a terrible arrow. You get something like this. Your rate is an annual rate and your period is a year. And one thing to remember if you're thinking about this is that the mathematics of this equation doesn't actually care how much time of the kind that we live through is involved in each period. It doesn't care how many times the Earth turns around in a year. That's a physical fact irrelevant to the matter. All it cares about is that there is some period of time. It simply cares if one of them or half of one or 20 of them are used up. Then it can calculate the value. But that it happens to be a year, the mathematics doesn't care. Banking is usually done according to annual rates. We think in years, even when the periods we're dealing with are sometime different from a year. So if you think of this as a problem with a rate per some period of time and the number of those periods, then you will be thinking accurately about how this problem works. If you get hung up on our live time, the actual years we're living through, you're sort of distracting yourself with things that are irrelevant to the mathematics. This example might illustrate what I mean if I take a very simple problem. So $1 that we're investing at 12% interest for a year. It's easy to work out that problem. Raising something to the power of 1 is no difficulty. This would be an equivalent. That is, I've adjusted the interest rate by dividing it because the periods are shorter and therefore the money earned is less. And I've adjusted the number of periods by multiplying because the same time measured in a shorter unit gives you more units. Now, those are equivalents, but the money is not exactly the same, and that's the relevance of compounding. The first simple problem, although we've used the compound interest formula because we've only got one period, just gives us the same answer we would get if we used the simple interest formula. The second formula actually requires us to do the compounding, and we get another 68,000th of a dollar, not even a penny, nothing consequential, but of course in the scale of money, the way finance deals with money, it could make a difference. Why aren't they the same? I have balanced out the interest rate and the period as I added more periods. I diminished the rate so that everything would reflect the same rate over time, so that I would keep it even. Why then do I get more money, even if it's only a small amount of money? Why do I get more money in the last formula? Well, and the answer to that is simple. If you stop more often and ask, how much money have I made to this point? And you put that money back in the principal, then instead of resting there without earning interest, it gets to work. And it makes a difference in the end. However we do this, when you put down your money at the first instant, it's as though it doesn't earn any interest until the end of the first period. And the quicker you get to that first period, the more money eventually you get. And this will lead us to a problem that we will face later. Can we work out the mathematics of thinking that your investment starts earning money right away, and that for any small fraction of time it earns a tiny, tiny fraction of interest, and that interest is always put back into the principal to earn more money again? Can we work out the mathematics of that? That we'll have to save for later. But what you will need to do the homework is to be able to make these transitions. If you reduce the period, how do you reduce the interest rate? And then how do you increase the total number of periods over the whole course of the loan, over the whole life of the loan, so that you have made the adjustments accurately?